Right, this is a brief introduction to the tangent function. As you can see at the top of the page, I've sketched it for you. It's a sketch because it's not been drawn by a plotting program. It's been done by hand, which is why it is a sketch. It would be a plot if it were done by a plotting program. You can see it repeats every pi. You can see that it approaches, as the function approaches x equals pi on 2, the function itself goes off to infinity. It never actually reaches the value of pi on 2. So there's an asymptote at x equals pi on 2, and every pi there's another asymptote going in either direction. All right. So the period is pi. The domain is all the reals excluding the set of points x, such that x equals 2n plus 1 times pi on 2, where n belongs to the integers. So if n is 0, then you have pi on 2. So the first asymptote here, pi on 2. Okay, the function gets arbitrarily close to x equals pi on 2, but it's not defined at that point, and it goes off to infinity as it does so. Likewise, as this branch here approaches pi on 2, it goes off to negative infinity. The asymptotes then can be defined as being at x equals pi on 2, 3 pi on 2, 5 pi on 2. As a sequence, you could represent as 2n plus 1 on n times pi, where n belongs to the integers, because of course you have the negative of those as well. All right, we could write tan theta as the ratio of sine theta to cos theta, so long as cos theta does not equal 0. Okay, in general, a trigonometric function made up of the tangent will be in the form y equals plus or minus a, some constant a, times tan of this argument here, which I'll put in square brackets, and the argument is n times x plus or minus h. H is a constant, a number. N is a number. That will affect the period, as we've seen in previous videos. Plus or minus k moves the graph up or down. Plus or minus h moves the graph right in the case of minus h, left in the case of plus h. N affects the period. It dilates it in the x direction by a factor of 1 on n. The a dilates it in the y direction by a factor of plus or minus a. All right, so it has a period of pi on n. I just want to have a look now at some of the symmetry properties. And just in relation to the symmetry property, if we take the first one, tan is pi minus theta. If we could just imagine like this. Now in the first quadrant, here's our theta. Now in the second quadrant, that's pi minus theta, the angle comes over here like this. This is pi minus theta here. Okay, now the tan of that, we could write that as being tan pi minus theta, sorry about my pen work, is sine of pi minus theta over cos of pi minus theta. Now if we just have a look at that, I'm going to be running out of space here. If you look at sine of pi minus theta, that's this bit here. Now that's just equal to sine theta. So we could write that as sine theta. Okay, cos of pi minus theta is this length here. Now that's just the negative of this length here, which is cos theta. So that's just negative cos theta. So what we end up with then is minus sine theta on cos theta. And so that is just minus tan theta. All right. And similarly for the other relationships, you could do the same argument in terms of sine and cos, and you'll find that tan of pi plus theta is tan theta, tan of 2 pi minus theta is minus tan theta, tan of minus theta, you could show, is just minus tan theta. And by the same thing, just doing the same thing as sine and cos here, just we've done here, just find their values in the different quadrants, and you'll see what the symmetry properties of this function is. Let's just have a look at an example here, just to finish off. Tan of minus 7 pi on 4. Well, if we look at the last symmetry relation, tan of a negative angle is just minus the tan of the positive angle. So tan of minus 7 pi on 4 becomes minus tan 7 pi on 4. Okay, now 7 pi on 4, well, that looks like it's in the fourth quadrant, so we could write that as 2 pi minus pi on theta, minus pi on 4, sorry, minus pi on 4. Okay, that's using this symmetry relation here. Okay, now we know that's equal to just minus tan of theta, or minus tan of pi on 4. Now there's already a minus out front, so the two negatives will give us a positive. Okay, give us a positive. And tan of pi on 4 is just plus 1. So we've ended up with plus 1. So tan is minus 7 pi on 4 can be reduced through the symmetry properties to just plus 1, because it's just equal to tan of pi on 4. All right, that's it.